we're looking at index laws, and we're looking at the first and the second index laws. The purpose of index laws is basically to build on what we've done before and to make things more efficient. And being efficient in maths is something that is important, and that's why we learn more and more maths, and we learn more and more advanced maths, because it makes us more efficient, which means we are more powerful, we can do things more powerfully, more quickly, with less energy and fewer resources. So it's a good thing. Okay, now what I'd like you to do is consider two expressions, and the two expressions are that one first and that one second. I'd like you to pause the video and complete this and that, writing it out in expanded form and filling out the boxes, and see what you get. So pause the video now. How did you go? Well, if you got it correct, you would have got 2 cubed, which is 2 times 2 times 2, so that would be this, this and this is the 2 cubed. 2 to the power 5, or 2 to the 5th, 1, 2, 3, 4, 5, so they're all going to be 2's. It's not very difficult, is it? How many have we got? Well, we just count them up. 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 2 to the power 8. Okay. Did you know there's a pattern? 3 and 5 together make 8. Just hold that in your mind for a minute until we do the next one. So we got 6 to the 8th divided by 6 to the power 6. So the 6 to the 8 is 6 by 6 by 6 by 6 by 6, done 8 times, and that's expanded form. 6 to the power 6 is on the bottom. Remember, over means divide. 1, 2, 3, 4, 5, 6. Now you could try and calculate all that. It's really unnecessary, because we can actually divide top and bottom by the same thing, which some people call cancelling. So 1, 2, 3, 4, 5, 6. Now at this stage there looks like there's nothing left on the bottom. In fact, every time we cancel that we get a little 1, don't we? These are all, we're dividing through, so we're actually leaving a 1 there. So it's not nothing, it's 1. We just don't usually write it down, because 1 times 1 times 1 times 1 is 1. But on the bottom we've got 1, 1, 1, 1, 1, 1, 1, which is just 1. That's where the 1 comes from there. And we got 6 by 6 times all those 1's, which is just 6 by 6. You could write 36 on 1 there, but 6 by 6 on 1 is just 6 by 6, which is 6 squared. Another pattern. 8 minus 6 is 2. Let's formalize this. The first example we just did shows index law 1, and it shows why it works. When we have a to the power m times a to the power n, do you notice that we have the same base? You must have the same base. These don't work unless you have the same base. So always look for the same base. It doesn't work with different bases. That's super important. Make sure that comes out in your notes. Same base. It must be. Must be the same base. Alright? You must have the same base. And if that is the case, we have that base in the answer, and we can write m plus n as the index. Now sometimes we only have letters and pronumerals and algebraic stuff, and other times we'll actually have numerals and we can have a basic numeralizer of the answer. So that's index law 1. Index law 2 was the second example we saw. Same base. Alright, we must have the same base. Again, there it is. Alright, and basically there's two ways of writing that. Those two things, that and that, are the same. What you do then is go a to the m minus m. So one, you add the indices, and in law 2 we subtract the indices. Let's have a look at some quick examples. We've got 3 to the 6 times 3 to the power 4. Are they the same base? Yes. Good. We can apply the index law 1. We have 3 to the 6 plus 4. If you look at index law 1, is 3 to the power 10. This says we can leave it in index form, so we don't need to calculate the basic numeral. It'd be a very big number. The next one, 7 to the power 9 divided by 7 to the power 5. We have the same base. Good. So we can subtract the indices. 7 to the 9 minus 5 is 7 to the power 4. The next one is a little bit more advanced, but take your time, you can do it. We have 3m to the power 4 times 2m to the power 5. What you should do first is rearrange it. All of these things are multiplied together. 3 times m to the 4, there's a times sign understood to be in there. 2m to the power 5, again there's a times sign in there. So we can rewrite it as 3 times 2 times m to the 4 times m to the power 5. And 3 times 2 is 6. And then we can apply, on the second part, we can apply the index law number 1, because we have the same base and we have multiplication. So basically we have times m to the power of 4 plus 5, because it's multiply, and that's 6 times m to the 9, which we can write as just 6 times m to the 9. Alright, now we're getting to the proper ones here. This one here, if you don't understand this one, you may need to rewind the video. It is a bit trickier and it's got more steps in it. So we have a mixture of index law 1 and index law 2 in this one, because we have times and we have divide. So be careful.